CactusCon. So the backstory is this comes out of work over the past. So I'm on a kind of a walkabout right now doing pure research, just taking a little break. And then this is something that I did back in 2018-19. I did the same thing. And I did my first work on anomaly detection back then and turned that into a bunch of machine learning anomaly detection things along the way. And so most of that was covered in these talks. I know that the second and third are on YouTube, and I believe the first one is too, if you want to see them. The contents, the contents are in the description, so I won't read you the contents, line by line. But this is basically the outline is, I'm going to show you just some examples of, well, what does large-scale exfiltration look like? What are we talking about? What do the large cases look like? What do the smaller cases look like? What does the data look like? What does anomaly detection look like? And how do we get to the point where we can actually do something fast enough to actually make a difference? Because that's the hard part. So the reason I've been so deep into anomaly detection is that it's not that anomaly detection is the silver bullet to everything. It's not. And there's plenty of areas for conventional detection in the cloud world as well. But there are also places where you run into this phenomenon. And so these are statements that came from retrospectives or public disclosures. And the one on the top is from a blog, a retro from a blog publication on a cloud incident. The one on the bottom is actually from an indictment because 3 of the 4 big cases have actually gone to prosecution over the past 6 years. But this quote in the middle where it says, it's difficult to differentiate between threat activity and legitimate activity, that is the best problem statement that I think anybody's come up with so far. It's better than anything that I have come up with in the past 5 years. That pretty much sums it up. And that the difference between benign and malicious activity is sometimes the matter of the smallest nuance, sometimes small enough that it's hard to see with your eyes. So in terms of, okay, so what do these look like? So working backwards, so last year we had this case, a large internet software web property had disclosed an incident where, and this one was a little complicated because it turns out they were able to get persistence on a software engineer or an SRE's home PC. And they were doing work from this, and it was a personal device. So it probably had no EDR, right? Because instrumenting personal devices is problematic. So they were able to get on this device, and they were able to obtain credentials while persisting on this home PC, and then they were able to, it turns out that the amazing thing is that this person was one of 4 that had access to some of the crown jewels and the most sensitive data in the place. And so they were able to get credentialed access as this user and then gain access to the data that this user had access to. This, by the way, this probably looks hard and complicated, but I don't think it's actually that. I think it's not that hard to pull off because if you've got credentialed access in a cloud account and you've got access to the log data, you're going to be able to see what IP addresses users are logging in from, for one. 2, you're going to be able to see what roles, policies, and permissions are in place, and you'll be able to enumerate which of the 4 users you need. And then from there, it's, well, what's their home IP address, and does anybody actually have a listening service with a vuln? In this case, they found somebody did. So in 2021, this was the first case where apparently there was, according to the indictment there and the disclosures, there was an actual insider threat case, meaning an admin actually had gone rogue and had started copying data and apparently tried to hold it for ransom in some shape or form, and eventually they were found because from what I understand, their VPN service they were using went down for just a matter of minutes, but that was long enough to leave his IP address in the logs. So you notice the reason I have circled that in red is in some of these indictments. In fact, it was, I think 2019 was when I started thinking about this, because some of these indictments, if you read them, they actually kind of give you ideas. They give you kind of a roadmap almost to some anomaly detection techniques. For example, Some of them will actually, because they go into great detail, as you can imagine, and they include things like what commands the user ran and how exactly they did what they did, because you have to go to that level of detail. So in this one, they talk about a command called get caller identity, which is basically like, it's like who am I in a cloud API is what it is. That's an example of like, like who am I? Who am I is something that probably wouldn't want to alert on that generally, because too many things use it normally every day. But if somebody is using it that hasn't used it before or doesn't normally use it, it could be worth taking a look at. In this case, there was also some defense evasion in that they were changing retention policies on certain logs, probably in the hopes of evading detection or frustrating detection in forensics. That again there's another opportunity there, because things like log retention policies, usually those don't change day to day. Usually when you set up a world in the cloud, you set up log retention policies, and you probably don't change them that often. And they're also, it may not be normal for a human to be changing those. It's probably more likely that that's been set up by automation in the course of setting up the world or environment where this was running. So there's another possible anomalous, one anomalous log event amongst billions if we can find it. 2019, this is possibly the most technically complex case, I think, where, according to the indictment, this was actually a former employee of a cloud provider, and she had, if what we read is correct, she had a fairly extensive depth of knowledge. And so what she did is, she did something that I think we knew was possible. I'm not sure how many people were doing it, but what she did is, she was able to basically be able to kind of bounce through a web application firewall service and get execution on the virtual instance where the WAF service was running. And that by itself doesn't necessarily get you very far. But what she knew then is that there's something called the metadata service. Anybody know what many of you are familiar. The metadata service, if you're not familiar, is the way that virtual machines get authenticated and so they can do work, right? Because most virtual machines are running back-end services and applications that are running Java, Python, or code or something. And there's not a human sitting there who can type in a password. There's just machines. So what happens is the virtual machines, they can call something called the metadata service, and they can say, hey, what roles am I authorized to use, and what keys and credentials can I use to do my work? And the metadata service was that you can use these roles, and here's your keys. And those keys they're called STS tokens, and they often are only valid for, I think 60 minutes by default. They're very short-lived, so the instances have to go back and keep getting new ones. So that way, if one of them leaks, then the risk is not super extreme because it's going to expire. But what she did is, she called the metadata service from the instance and was able to obtain credentials. And these credentials, for some reason, she was able to use these credentials to gain access to S3. Now, she probably had to go back and obtain credentials several times in order to take this much data. But she was able to take credentials in order to access S3 data. And so you notice that this is kind of where the light bulb went off in my head in 2019, because you notice they actually say, the WAF role account does not, in the ordinary course of business, invoke the list buckets command. And so that is when I realized that, well, you know what, actually not many things do normally invoke the list buckets command. So whenever we see a new user context or any number of other anomalies, it's often worth looking at. So 2016. So this case, in fairness, this is not just a cloud case. This was a large, complex intrusion set with many dimensions to it. Probably much more of it was endpoint than cloud. And a lot of people worked very hard on this. And I am not the expert on this case, but from what I know about it, there was a cloud dimension to this, and there was something done here that was novel at the time. We hadn't seen this done before, and I'm not sure at the time, I'm not sure it even had occurred to anybody. And that what happened is, if you're persisting in an environment, if your goal is to do bulk exfil, well, you want to, follow a least work algorithm, right? You want to do the least amount of work you can, and you want to do it as fast as you can, because the longer you take, the greater the chances somebody's going to notice. So what they realized is that rather than just doing a bulk data transfer using a service, or maybe, if they used, say, SFTP or SCP or some other, if they did it from an endpoint, that could be noticed, probably might be noticed by an endpoint or EDR tool. So what they did is they shared snapshots of the virtual machine fleet with their own account. Meaning, the reason, and what that means is a snapshot is essentially like, if you've ever used something like VirtualBox or VMware, a snapshot is basically just a point-in-time image of the disk in the file system. It's what it sounds like. And you can take these in cloud too. And you can take a snapshot, and then, like I just did, I just reconstituted a cloud instance from a snapshot I took in 2019. And so you can bring back entire things that have been down or that have been kind of archived. But so what they did is, so the reason you can share snapshots is for two reasons. Is that sometimes different teams in the cloud, it's common that different dev teams often have different accounts. Because it provides a kind of like a sandbox or a safety system. So that way, one team cannot accidentally delete the other team's work or mess up their world. So it's kind of like a safety thing. But increasingly, though, one of the things I talked about last year is that increasingly, security and observability products and services too are increasingly making use of snapshots. And what I mean by that is, like, if you heard about so-called agentless security products, what they will do is they will scan they'll scan or examine your snapshots looking for malware or suspicious things. And sometimes they'll do that in your account, but sometimes they'll share the snapshots back and do it in their account too. It can happen either way. So there's again, this is not something that we can just alert on generally, because there's just too much normal snapshot activity to just start alerting on this, willy-nilly. In this case, though, one aspect about this that's worth considering is that my understanding, though, is that this snapshot sharing activity was the credentials that they had the credentials of somebody who was more of a business user than an engineer. And it was somebody that probably didn't work with snapshots and probably didn't actually even make that many changes or commit changes to the cloud environment. I mean, it might occasionally, but probably not like as much as an SRE would. So the user context here would have probably been an extreme outlier. So in addition to this, there's a whole long tail of smaller cases that you haven't heard of because they weren't big enough to make the news. And so just to summarize these, you can find these on GitHub. There's a researcher named Rami Mack who has cataloged these up on, you can find them on GitHub. And so what I did is I started looking at these, and I noticed that they're broken out into two lists. So first they're listed they're listed as the ones that were reported by vendors. And then there's another section that were reported by customers or end users directly. And the thing that's interesting is that, so what I did is I did a simple quick and dirty classification of these and just tried to do a classification on, was the vector in these incidents, was it an endpoint intrusion set where they got persistence execution on an endpoint, or was it credentialed access where they just had credentials access in the cloud APIs and they didn't even need an endpoint? And so I labeled them. And so in the vendor reported cloud incidents, it's actually almost half and half between endpoint and cloud credentialed access, and there's maybe 12 points of unknown, or the ones that I could not cleanly label. I just left them as unknown to come back to later. But look what happens if we label the customer reported incidents. If we do that, then execution persistence in the endpoint, so the endpoint vector is 11%, credentialed access is 85%. And if you look at these side by side, that's a huge difference. And I don't know why that is yet. I think this deserves further investigation, but I think what it means is I think there are two possibilities. And one is that the vendors are finding more endpoint intrusion sets because the vendors are doing more kind of endpoint security EDR type managed services, and so that's what they're seeing, I think, maybe. And the cloud, the consumers are either they're doing more detection of credentialed access, or maybe they're not, but they're just eventually figuring out that when they have an incident, that the vector was credentialed access. So in terms of the data, just a quick intro to like what data are we even talking about? So there are 3 major clouds out there. In AWS, the primary log source is called CloudTrail, and CloudTrail will give you a record of just about every API call that happens in your account with a number of details. And there are comparable audit trails in Azure and GCP. So what you see on screen here is I've just put a few fields on the screen. So every event has a source IP address. The event source is the name of the service, and there are almost 1,000. There are several hundred services last time I checked, and there are 13,000 actions in total last time I checked. So there's a big space. So the name of the service, like EC2, is where you run virtual machines. S3 is a blob storage service where you can store files and great bulk. And there are a whole number of management and lifecycle features associated with these. Run instances is what it would sound like is when you want to start a virtual server instance, you call run instances. List buckets is if you want to say copy the contents of, so an S3 bucket is basically it's an object store. It's a named object store that can contain folders and files is really what it is. And if you want to copy the contents of an S3 bucket, unless you already have the names of the objects, you generally have to call list buckets first and get the list and then go and request the objects. And then modify snapshot attribute is what we'd seen previously where if you're going to share snapshots with another account, you would call the action that results in that event. There's not a one-to-one between API. The API methods are called actions. There's not a one-to-one between the action name and the event name and the CloudTrail, so it takes a little bit of, you have to kind of spend some time with your head in this before you know it really well. Now, what is useful to do that it doesn't really happen automatically, but the other thing that's really useful to do is to enrich these with geographic data and autonomous system network name data. And you can do this using something like MaxMind or something else, and that gives you an idea of where in the world is the call coming from, and what network is it coming from at that location in the world. In this case, it's coming from a cell provider in San Francisco. All right, so let's get into some cloud threat hunting, and I'll give you some actual examples and some queries. And so here's a list of, these are all exfil relevant events. Some of them are related to S3, some of them are related to key management, and some are related to database services like if you see a restore DB instance from DB snapshot. If somebody is trying to exfil a database, you'll often see them do that. Why? Because threat actors like to, rather than trying to take the live database, threat actors like to do it this way I think it's just easier. Now, I've measured these, so over the past, years, I've measured the frequencies of these events across a wide variety of large-scale AWS environments. And in each case, the frequency of these and the prevalence was low enough that it is feasible to alert on these. Now, the false positive rate is not going to be 0. And what I would say about that is that it's not necessarily a false positive, because if we get an alert on one of these, it's not a false positive, because if we get an alert, it means that that action was called and it did in fact take place. But what you can have is there's a third problem in addition to false positives, false negatives. The bigger problem is noise, in that you will occasionally get detections on these that while they are unusual, they are benign, because there are benign outliers. In cloud environments, there's a long tail of benign outliers, and that's part of the challenge. So if we wanted to turn these into alerts, what I've done here is I put these into Sigma format, just because Sigma is a nice vendor-neutral format for rule languages. This is not a complete Sigma rule. This is just really, it's mainly just showing you the detection logic section, because the whole thing would just be too big to fit on the screen. But I will, I'm planning on sharing and open sourcing most of this in the near future. So you'll be able to, you don't have to worry about trying to, whatever, you'll be able to get this. But these are exfiltration related actions. What I would say about these is I wouldn't necessarily take all of these and turn it into like a Sev1 critical alert and put it into a queue. I would first run some queries and just see what the frequency of these is, and just see if you can identify any normal benign outliers that you can filter out and screen out. And then when you get to a point where you can see that you're going to have very few of these, I think you could turn them into alerts for investigation, or if you don't want to turn them into alerts, you can always just feed them into a threat hunting workflow instead, because that way we're not paging somebody or creating annoyance in the SOC. The other thing, though, I would say about one thing I should say about S3, or else I'd be remiss. So S3 logging is not on by default, and I think object storage logging is not on by default in most cloud providers, and the reason is because it is if you're operating at even medium scale, it is a fire hose of log data, because you will get an audit event for every read, write, change event. Think about if you've ever looked at file events in, say, like Process Monitor under Windows or something else. File events are supernumerary. So if you're going to turn on S3 events, I'd say do it very carefully. Start with your smaller buckets, maybe your dev test environments, and then start with the smaller buckets in prod and work your way up, and just to make sure that you don't get a big surprise. It's not the end of the world. If you turn it on and you see, oh my God, there's too much data, well, you can turn it off again, and it won't necessarily be the end of the world. But don't just turn it on and walk away and go on vacation for 2 weeks, because I have seen, the largest I've seen is, if you're using S3 as a data layer at scale, I've seen people doing 9 billion events a week, and it's not hard to get there. All right, so then we can alert on these. What about these? So in one case, we saw the equivalent of who am I, like get color identity, and then in another case, we saw the list buckets and the snapshot events. These are not alertable, at least not because these exist in such numbers that if I were to come to your SOC and turn on these alerts and start sending them to PagerDuty, you would chase me up a tree and set fire to it, right? Because there's just no feasible way to turn these into alerts. At least not without, you would have to write so much branching logic to get rid of the normal outliers, and you would have to maintain that logic indefinitely. It's very hard. So these actions, what I found in the environments I've studied at scale, is that these actions are really not just alertable generally. Like, we cannot just turn alerts on these and walk away. So what do we do? So this is why I started down the road of anomaly detection. So in terms of anomaly detection, so this is actually, by the way, this last technique on the screen, snapshot modification, that actually has its own tactic and technique ID in the attack matrix, and that was actually that came out of that 2016 case. But you notice that what they say is, MITRE also doesn't say, like, if you're asking me, if you're skeptical and saying, well, why should I do anomaly detection? I can just do alerts. Well, MITRE themselves tell you, they talk about anomaly detection, and here they say to look for anomalous activity, and that's good advice. And in fact, if you read the entire matrix, it actually talks about anomaly detection extensively, and there are literally thousands of keywords related to anomaly detection or baselining or various things. And so, I think it's becoming clear there's increasingly consensus that we need anomaly detection, and by that I don't mean it's time to just throw away everything else and just do anomaly detection machine learning. I don't think so. I advocate what I call detection science, which means use the best detection technology and tool for the job, which means a combination of conventional alerting, machine learning, anomaly detection, and possibly other things. So some examples of anomaly detection. So let's get more specific. So one thing that we have that's working in our favor is that compared to endpoint, if you think about what an attack tree, think about drawing an attack tree for all the possible ways you could get persistence or go after a Windows endpoint. And it would be large, right? But the attack tree here is relatively simple because, at least at the top of the tree, because if we want to persist in a cloud environment, there's really, you have to choose one of two routes. Either we're going to get execution and persistence on a virtual machine and then move laterally through the virtual networks from there, or maybe try to escalate into the control plane. Or we're just going to go and obtain credentials from somewhere, maybe from a post in a code repo. Maybe it's from somewhere else that leaks credentials, maybe via phishing, maybe some other vector. But and the method on the right, or rather, in the method on the right is assuming we're doing execution and persistence on a virtual machine. On the left, we're just forgetting about the virtual machines and we're just logging into the cloud API using somebody else's password. And this can be it could be a username and password if we're logging in a browser interactively, or if we want to use a CLI tool, if we want to use an SDK or like a Python or Java tool, we can use a key and a secret key, assuming we can get those from somewhere. So, in terms of what are we looking for in general, it's relatively simple. So that's one thing that's kind of going well for us. This is a simple K table of some of the most productive anomaly detections that I've used so far. So what I mean by human user context is I mean the user context or the identify of a human user that's working in a cloud account. And the reason is that doing anomaly detection on human activity is a little muddier than programmatic activity. Automation and programmatic activity, it tends to not change that often. Now, well, I should say there are aspects of it, like they tend not to change, say, geographies or network names, right? Because programs they don't have legs and they can't get up and fly to Europe, right? So they don't do that. But programmatic activity is complicated though too, because one of the possible pitfalls I think is when people talk about baselining. Baselining is not the panacea that it sounds like. And the reason is because cloud environments that are highly automated are like living things, and that they change. Basically infrastructure as code means that every time somebody checks in a code commit, the behavior of the environment can change. From, you can baseline it in the morning, its behavior can be different in the afternoon and the next day and the next day. So baselining, I mean, it's not that I won't say don't do baselining, but baselining alone is often not enough. What we need to do is look for outliers, in some cases look for outliers without necessarily considering or starting from a baseline as a foundation. So human user context means a human username. In AWS, every user has what's called an ARN, which is basically a unique identifier for a user. Service means the name of the service that they're working in, whether it's EC2 or S3 or there's hundreds of others. An action is basically the API method. An API method name is called an action. So when we see, and what we're looking for is in the match between the two, these are anomaly detection methods. So when I say new, I'm looking for combinations of human user context, service or action, and either the source geography or the source ASN network name, or user context in the case of service or action. Looking for events that are either very rare or better yet, that are new and have not manifested before in the 1 to 4 weeks or however much live data you have. When I say concurrency, what I mean is sometimes when you have, I've got a slide that will kind of diagram this for you, but sometimes with concurrency, you have to look for same user coming from two different places at the same time, and two different places that you can't reconcile. And it's muddier than it sounds, because most people have 2 or 3 devices, and like at home I have at least 2 ISPs. I have one for my internet and one for my cell phone, and people change IPs more often than you think. But what's less common is people don't change network providers that often. People do roam around to different geographies. Like in Europe, you can roam across 3 or 4 countries in a single day. Here in the US, it's less often. So sometimes it comes down to whether it's the other thing you can look for is if you have a case of concurrency, so like, why is Bob logging in from here and from Timbuktu at the same time? Well, one thing you look for is, well, where is his, if you have instrumented laptops, where is his laptop actually? Like what country, geography, and ASN is his laptop in? Now that doesn't necessarily mean you've got a true positive, because if he's on a VPN, in the era of work from home, and VPNs and everything else, this has gotten a lot muddier than it used to be, but it's still useful because of this. So this is what I'm trying to diagram here. Is the reason for using the combination of these 4 techniques is that in this graph, the horizontal axis is the time frame. Has the intrusion set been going on for a short or long amount of time? And the vertical axis is the event density. Is the intrusion creating a lot of events? Is it noisy? Or is it stealthy and creating few events? And so different anomaly detection methods perform differently and better in these circumstances. Like, for example, like a new combination of certain new combinations of, say, user context, source, and service or action. Those actually perform better than rare at finding true positive, suspicious, and malicious activity. The only thing is that something like that is only going to be new for a short time. Because if somebody is persisting in your account for days, weeks, or months, then eventually what they're doing is no longer new. So if you don't catch it early on, then other methods come into play, like rare. So even if somebody's been persisting in an account for a while, if it's, say somebody is coming in as a business user, or somebody that doesn't normally do heavy amounts of work in the cloud APIs, then the services and the actions they're calling and the events they're creating are often rare for the user or the source geography or the ASN, or possibly both. Geographic in origin is what I mean by concurrency, because if you've got somebody like, so if somebody is using automation, say like somebody comes in with a tool like Paku or Bark, because if somebody gets execution on a virtual machine and wants to start asking like, well, okay, I've got, if you've got persistence on a virtual machine, the first question is, well, what can I do? Like, what roles can I access? And what can I do? Can I become a user? Can I get to admin level privileges? Can I do anything? So often what you'll see is people will run tools like Paku or Bark or other scans in order to just kind of enumerate, like, can I do this? And can I do these other 5,000 things, or yes or no? And so in that case, the event density gets very high very quickly, which starts to look like benign automation in terms of density. But where you can see that, though, is that kind of enumeration will usually send the error rate like just through the roof. It'll briefly create an enormous spike in errors with a standard deviation that is thousands of times larger than any normal day-to-day variance in error rates, and sometimes in event rates too. So sometimes you can see it that way. This is an example. So this is an example of outliers with a combination of event name or action and autonomous system network name. And so in this case, if we were to see this entire list, what you'd see is that after we get through the first 3 to 5 lines, the numbers get a lot bigger because the normal activity occurs. When we see normal activity, the event count is in the thousands or the hundreds of thousands or even the millions, because most programmatic activity, it either goes on all day every day and creates huge event density, or not at all. So when we see outliers like this, this could be, it's one of two things. It could be an SRE, or somebody's just troubleshooting something, or it could be somebody just poking around. But if it can't be reconciled as a legitimate user, then this can be a productive hunt technique. Here's an example of combination of user agent and event name. And in this case, list buckets is actually, so there are a few here, like there's a few good outlier combinations here, including some console logins from user agents. Like which is weird, right? Because most users don't log in 3 times. If you have data going on for a month, most users don't log into the console 3 times. They either log in 300 times or not at all, unless it's somebody who's just logging in for the first time for some strange reason. List buckets is even stranger. Like not that many cloud users even call list buckets. List buckets is more likely to be called by automation than by a human. So seeing that from a browser, or in this case, it's coming from an automation tool, but seeing outliers like that, that is, I think, a promising direction that I'm going to come back to. So in this case, if we wanted to generate these kinds, so the detection logic here, the query logic essentially is we're looking for the event name getObject. GetObject means you're requesting a data blob from an S3 bucket. And in order to do user agent hunting, this is the list of user agents that I like to filter out, because if you start plotting user agents, what you'll find is even in a medium-sized environment, there's a very long tail of normal outliers in user agents because there's just so many devices out there. So you have to get rid of some of those. Like here, for example, these are there's a screenful or so of user agent outliers here. And what you'll find is that one of these, maybe 2, might be suspicious depending on where it's coming from, but often many of them will be benign. All right, so the other technique in the chart was talking about spikes and lows. So another thing that's useful is plot the variance in event and error volume, and take, say, like the top half dozen or so standard deviations. Don't do a hard-coded standard deviation. Like, don't say, give me a standard deviation of 3 or 6 or whatever. Just say, give me the top end standard deviations. And what you'll find is that if there is if there's a surge in activity going on, there'll be spikes with standard deviations that can be hundreds or even thousands of times larger than what's normal in the day-to-day. And so they're easy to find mathematically. But you can also, they're easy to see. If you just plot event names by time series, it's easy to see. And the same thing for errors. Like right here, this is not a large data set, but you can see that an error spike is also really easy to see. So if you plot these. And the great thing about error spikes is they don't have a benign explanation. Now, it doesn't necessarily mean there's an intrusion, but it means that either something is just broken or something can't authenticate for some reason, or there's something stranger going on. The other thing is error spikes and rare errors will also, there are observability applications because they will sometimes predict. I've had cases where rare errors will predict that a service is about to fail within the next 1 to 2 minutes. So that can be useful. It's kind of a nice bonus for observability teams. All right, so then what if we apply these volumetric techniques to look for S3, to look for bulk data exfiltration, right? So we can do that. So some of these examples were implemented in, there's actually, in the open source version of Elastic, there's a function called significant terms that can be used to do anomaly detection. And I'll publish some examples. I published some examples of that in the past, but I'm going to expand on that and release some more this year. But this is done in a Jupyter notebook. And so here we're plotting, if you plot event volume by name, you can see that on a couple of occasions there were some big spikes in getObject events. Now this is not something we could alert on. This is useful as a hunting workflow, but think of it like it's almost like plotting web activity, right? Because if you have if something in your web environment goes viral, or it's Black Friday, or you're just having a big day, then web traffic can go through the roof. And if S3 is your data layer, then S3 events can go through the roof too. Not because there's anything suspicious going on, but because there's just some kind of a traffic event. So you really have to, if you can deal with the cost of keeping S3 events around for, say, a matter of weeks, then it's easier because you really need to, in order to see it this way, you really need to plot these over a bit longer time. in order to see when something is really outside the norm and it's just not within the realm of normal peaks and troughs. This again is get object volume by bucket name. This again, there are non-malicious explanations for this, but if somebody was taking everything in a bucket, you would see a big spike in this. And you can see there's a spike here. The blue is a spike in get objects for a particular bucket name because something is taking every object in the bucket. And you can look at the user context and say like, well, if that's your automation, that's probably fine. That's probably just data layer maintenance. But if it's coming from a source, country, or network that cannot be explained, then it's worth taking a closer look, right? Another good one is, rather than just doing a simple plot, plot the biggest spikes in data volume by action name. So we have get object, head object, put object is a write, list objects is a list, like it suggests. Rather than just looking at the data, so sometimes if you plot these spikes and say, give me the largest spikes in these events over time, you may be able to find something that's not just a traffic event, but actually is exfil going on. Now, at the same time, though, the thing is the problem is that we can find exfil this way, but the limitation is that in order for us to find exfil this way, it has to be underway in some fairly significant volume, and there has to be a pretty large amount of data going out the door. So we can find it this way, but we may or may not be able to intercede in time to actually make a difference. We may not actually, we may be able to detect the data loss, but the business is going to say, well, sure, you can tell me that all our data just went out the door, but why didn't you do something about it? How can we prevent this? How can we disrupt this is the harder problem, right? So it's hard to do that with these volumetric methods. So in terms of just some learnings about data cardinality and shape. So what I would say is using and reasoning about source IP addresses in general is not that useful, because what you'll find is that there's a relatively small number of IPs that generate massive activity, but then there's this long tail of IPs that generate small amounts of activity, and there's too many IPs and there's too many normal outliers to try to chase those. Also, the fact that making lists of IPs is not always that useful, because a lot of those IPs are going to be coming from inside your own cloud environment. And so there's no point in listing those. There's no point in chasing those down unless there's something already inside the house. So this is the reason why I like to decorate these with source autonomous system name. So if you look at this, there actually are, in this data set, there actually aren't many outliers in source ASN. And why? Because, well, this is S3 events, and it's actually not normal for people to be just pulling down all of your S3 data from all over the world and all over the place. Usually it tends to come from the same places every day. At least data layer activity, bulk data activity tends to come from the same networks, not a different network every day. So this is, and again, this is much more manageable than trying to manage lists of IP addresses. Source IP address including, so if we exclude local and cloud provider IPs, meaning we're only looking at external IPs, then it gets a little bit more manageable, but not to the point where I don't think we could contemplate turning these into alerts. This would be a threat hunting workflow at best. And when I say excluding cloud provider IPs, what I mean is basically this logic. And this is what's great about source ASNs. So if we wanted to list and say, I want to ignore every IP address used by my cloud provider, you would have a list that's probably into the millions. And that list may change month to month. And that is just going to be, you could do that, but that's going to be a very, very expensive query filter, right? Versus if we do it with ASNs, we can just use names. And we can say, okay, exclude the source IPs that are labeled with my cloud provider name, and in this case, there's two cloud providers here. And then in order to get local activity from inside the VPC, exclude anything with a 1918 private IP, right? Because if it's coming from a private IP, it's coming from somewhere in your VPC. It can't be coming from out in the world. So if we do that, you can see that excluding anything from inside the cloud provider and only activity coming from out in the outside world, then the tail of, so most of the activity, like the overwhelming majority of the activity comes from 4 or 5 autonomous system network names at the end of the chart, and then there are a handful of outliers, but it's pretty small. But we can refine it better. And what I would suggest is, in addition to the last filter, confine your searches to your production account. Why? Because in the dev, test, and staging accounts, there are devs in there that are working from home, and they're coming from all over the place. And there's going to be an enormous variance in behavior. But if you're looking at prod, the variance tends to be smaller, in that there aren't usually, like, prod's usually not a free-for-all with people logging in from all over the world and doing whatever they want. Prod's usually much more regimented, and it tends to be more automated. There may not even be human users in there, and if there is, in some environments, even seeing a human in prod will launch, and it will trigger an investigation. So it's a lot less muddy. It's a lot clearer there. So exclude local and cloud provider IPs. So we're looking for only stuff coming from the internet and only in our prod account, and then aggregate events by basically, are they read or write data events? And then we get this. And this is, we can see that almost all of the normal activity, in this case I'm plotting them, instead of by ASN, I'm plotting them by country name here. You can see that almost all of it comes from 2 countries, and the only outlier we have here is Canada. And so that's pretty good, because one outlier, in terms of, this is almost good enough to start thinking about alerting, because this would, with one outlier, this would produce so few alerts that it would probably not annoy anybody. And so good signal. And this is by ASN, and again, you can see that almost all the activity comes from 3 ASNs, and then there are a few outliers, and then anything that's an extreme outlier is possibly worth interesting. All right, so what about non-volumetric? What if because there are cases of where, because data exfil doesn't have to be volumetric or big enough that we can see it in a plot, either by counts or standard deviation or some other means, right? It can be smaller data exfiltration cases can still be critical. So let's look at an example case study. So this, so I had to blur most of this out, but I'll explain to you what's on the screen. So at the top we have, the URL contains the URL to a data object in an S3 bucket. It's basically a GET request that says, I want this file in this S3 bucket. And then the second red box, you can see this field called XAMZ credential. And then we start to see a value. Anybody know what that value is after XAMZ credential equals? Right, it's an STS token. So the question was, first of all, why is this S3 request even coming from? This was coming from an ASN in a country that could not be reconciled because there was no business relationship and nobody was there. But secondly, why in the world would it use an STS token? But third, if it's not one of our people, if it's not one of our employees, where did they even get an STS token, right? Because you'd have to get on, you'd have to be inside the environment in order to get one. So who thinks, so here's our, this is one of the more complicated cases I've had. It took some doing to run this to ground and to make a determination. So show of hands, who thinks this is malicious? Okay. Who thinks it's benign? Okay, so interesting. There's very few responses. Who doesn't want to make a decision? Right, most of us, right? You know what? And you're right. It's hard because this is a hard thing to decide, and the cost, the impact of an error either way is very bad. If you err on the side of this is suspicious, we need to shut it down, and it turns out to be benign and it's in prod, then your name is Mud, and you're not you're not in the doghouse. You'll be under the doghouse. But if it's suspicious or if it's malicious and it's an intrusion, and again you don't react fast enough, then again it's why didn't we find this? So it's hard. So anyone looking at this, does anyone know what this is? What this came from? If you don't feel bad, because it took 3 of us some time to figure this out and chase it to ground. So it's actually this. So it was actually an NPM library that can do S3 requests, and it was being pulled into a build that used Node. And so what happens is, and this is one of the more complex cases, but essentially what's going on here is there's a web application that has the ability to go and grab files from computers at a user's request because reasons. And so the user says, I want this file on that computer, and it says, okay, I'm going to go get that for you. And so then the way that this was done, this was something that sometimes you'll find things like this that were probably coded some time ago, and you might not do it this way today, but what it does is, long story short, the middleware service asks an EC2 instance to go get this file. The middleware service is able to get this file, and the EC2 instance puts the file in S3 using an STS token, and then the middleware instance then sends this request with the STS token back to the browser, and the browser makes the request to S3 using the STS token and authentication keys in order to pull that file out of S3, right? So if any red teamers here? So there's a few. If you want to I would say, if you want to exfil files out of an environment, if you find there are applications like this, if you want to exfil files out of an environment using S3 in a way that's going to take me quite a lot of work to find out who's on the other end of this is the way to do it. And I would say, if you can do this, I would say the chances of them detecting it and attributing it to you are 50-50 at best. Just because the amount of work that you would have to do to first of all, to even, to see the events in step 2 and 3 and turn them into anomalies and get all of that into the hunting queue, a lot of stars would have to align. So this is the relevant query. So because STS token access to S3 is actually pretty unusual. And I only saw it in one of my environments that I studied. And it's just not, because, one, why would you want to do it? You don't need to do this because today you can do you can give what are called pre-signed URLs. So that way a browser can request a file from S3, but you don't need to give it, you don't need to provide keys or tokens or credentials or anything like that. So there are better, more secure ways to do this. So this relates back to the 2019 case. If you see S3 access coming from outside the cloud environment using STS tokens, it's usually worth an investigation, even if it takes a while, because it's either it's something strange is going on, or possibly it's something that was coded maybe sometime in the past and probably maybe needs to be refactored to use more secure methods, not only to reduce risk but also just so we don't have expensive threat hunters trying to chase things down like this. So, all right, so how do we get left of boom, right? How do we start to get earlier enough in the cycle that we can start to do something about this? So at ShmooCon, if you're at ShmooCon, some of the researchers were talking about what they call invariants, looking for invariants for detection, meaning an invariant meaning something that they will always see in the logs, like say looking for something like credential dumping from LSAS. There are many different rules and methods of searching for alerting on that. And they're talking about what we need is an invariant. It doesn't depend on a particular code path, but something that we will reliably always get when that happens. And the good news is that in the case of S3, unless you already have a list of objects in the buckets from somewhere else, if you want to grab every object in a bucket, you're going to have to call list buckets first. And there are similar events like list tables in some of the database services. And those actions are not, they're usually not very high volume, but they also tend to be low variance, meaning that they tend to come from the same, they tend to be called from the same place every day by the same thing every day and the same user every day. And so when you see outliers in where these are coming from or who's doing it, it's often suspicious. So what are our options? So this is where it gets more complicated. So one thing we could do is if we have an extreme, say an extreme list buckets outlier, well, we could intercede with automation in order to, and we could shut it down in order to. Now the only thing is though, is I would say that this has to be approached even more carefully, because if we're going to interfere with an API call in a cloud environment, first of all, that is going to have to be socialized and agreed by everyone. This is what we're going to do, so there's no surprises, and everybody has to agree and understand, okay, we are going to, in the case of this or one or two methods, we are going to re-authenticate these. So you could take action by possibly removing the access policy or disrupting in some other way in order to disrupt the data request in that way. Now what has to happen though next is that whatever automation is doing that, whatever SRE responds to that, that PagerDuty alert says, oh, this failed, they've got to know how to re-authenticate this. And really, ideally, you don't want to have the SRE getting on a conference call with InfoSec and saying, hey, can you please turn this back on? There's going to have to be a very clear, low-friction process so that people can, if they need to re-authenticate this and get it going again, they can. And this is not a culture fit for every organization. Not every organization is going to be able to want to have this kind of action. So it depends. The other possibility is, one of the things I'm thinking about is prediction. And that's going to take quite a lot of data science machine learning work. But if we could start to predict some of these, then, well, if we could achieve that, then obviously we could make a difference by possibly averting the thing in general. And then finally, one other thing we're working on is we think there is an LLM application here. We're working on an LLM project. We think we can make it work. The question is whether we can afford to bootstrap it ourselves and the training cost. But if we can make it work, then it wouldn't prevent this from happening. But in the case of my complex case example, it would give you like a co-pilot, kind of a ChatGPT co-pilot thing that would give you the answers that you need in order to make a quick decision on whether or not this is probably benign or probably suspicious. Make that decision a matter of a minute or two instead of a day or two like it's sometimes. So I'm hoping to have more on that this year. So, summary approach. In summary, I'd say take a detection science approach. Machine learning is not a silver bullet. It's not the answer to everything. Use the best technology and tool for the job. If you can find something with an alert that takes you 5 minutes to create, then that has a better resource to kill ratio than a $5 million machine learning model that takes 3 years of engineering time. So stay close to your users, especially with this stuff. I like to make sure that nothing I'm doing is annoying the users and that they're getting value from it. If you do go the route of automation and re-authentication, never make sure you can never surprise anyone with that. You have to make sure it's very well understood, and there has to be a very clear mechanism for overriding that. So that is my talk.